Hey everyone, Fred from Litemint. So I took this opportunity to create some educational material, code and a live game demo as well to make sure developers find an easy, practical entry point into building their Web3 games and metaverse projects with Soroban smart contracts on Stellar. So the code is freely available on my GitHub, and you can follow along with this video. You will find the game client and the Rust contract code as well. So I will try to show you how simple it is to build a Web3 project from scratch on Soroban, and we will also go through the most common use cases of Web3 gaming. So I will show you how to implement in-app purchases through smart contracts, also reward players with achievement NFTs. We'll see how to validate the gameplay, so including, for example, in our game, the pool physics and some time-based element. But I think decentralized gameplay validation is very important for Web3 games. You can provide probably fair mechanism, for example, or even manage an in-game currency through smart contracts. So it's a very powerful mechanism. We'll also see how to use auth and create admin functions to manage your game assets on the blockchain, and I will show you how to efficiently store the game data as well on the blockchain with state expiration. Soroban has a very unique and cost-effective mechanism to manage your data. And then I will also show you how easily it is to integrate the Freighter wallet. It's only a few lines of code, but we will go through that, and also how to use custom types for interfacing between the client and the contract, for interactions between the client and contract, and many other things. But it's going to be technical content. We are going to go through the code, so let's get started. Alright, so if you go to my GitHub, I'll provide the link. You will find a project called Soroban Snooker. You can just clone the repo and follow the instructions to get your environment set up. I'm gonna skip this step and go straight into the code. Alright, so first I'm going to give you a very quick demo of this Web3 game. So when you press play here, it asks you to sign a transaction. So make sure your Freighter is in experimental mode. So you connect to FutureNet and you just need to approve the transaction. So the contract is invoked and will generate some pool table with randomly positioned balls, and the goal is just to put the ball into this. Usually I'm very bad. Oops, I missed this one. Let's see. Okay, let's try this. Not bad. Right, so after you need to sign another transaction which is going to validate your score on the smart contract. So we send all the ball's velocities. The contract runs the simulation on the physics and then returns the score based on how good you performed. So I'm going to start by talking about decentralized gameplay validation. I think it's a very important topic for Web3 games, because now what you can do with smart contract running on the blockchain is to validate a few of your gameplay elements in a decentralized manner. And it can be used about for anything. Here we use it for validating the pool physics on the smart contracts, but you could also use it, for example, for your smart contract to provide probably fair mechanism to your games. You could also use it for the smart contract to manage a full in-game currency. So it's also a very interesting topic. Now there's a few things that you need to consider when you do so, is that you run in smart contract environment, which is a very limited environment in terms of resources and the number of instructions that you can run. It can be very costly. So for example, here I was hitting some issues with the collision detection, and I had to bypass the square root calculation. Luckily we don't need to know the exact distance value, but there's a few tricks that you will have to work around in order to make sure that things work. Another limitation on Soroban is that it doesn't have access to floating point arithmetic, so you need to do all your calculation in fixed point arithmetic. But apart from that, obviously it's a very powerful feature of running games with smart contract as the backend. Okay, so now I'm going to go through the contract interface, and that will allow me to talk about all the other topics that I mentioned earlier. Now you will see that this interface is not generic at all for the sake of simplicity, but if you implement especially large projects, I would recommend that you use interfaces, so threads in Rust, in order to implement shared behavior like polymorphism and code reuse as well. Usually that's what you want to do. If you come from C++, that would be the equivalent of abstract classes with pure virtual functions. But for the sake of simplicity here, we just kept a very non-generic interface. So the first thing that you call on the contract is initialize, and the interesting part here is the fact that we use the instance storage to store, for example, the administrator of the contract. And that's usually the storage that you want to use to store this type of information that allows you basically to store data that will share the same lifetime as the instance of the contract. But there's additional storage that are cheaper, and that's what, for example, we use in the insertcoin function. So when you click play on the game, we call insertcoin and require an authentication from the player so that he can make the payment to the contract address. And we generate some game session data, which is the pool table here, and we store it in the temporary storage. So what you store in the temporary storage cannot be restored if it expires, but that's exactly what we want to use for this type of transient data that are pertaining to a specific game session. Right, so next, the game client is invoking the play method on the smart contract to communicate the strike data. So that's the ball velocity that we run against the algorithm. An interesting point to mention here is that if you need to implement any time-based logic on your contract, you can use the ledger timestamp or the ledger sequence here. So for example, here we use it for seeding our random number generator. And we also use it to make sure that no more than 3 minutes elapse between the time we call insertcoin function and the play function to prevent cheating, for example, because someone could just try forever on the client side before it submits the data to get the perfect score. And then if someone gets the perfect score, then here this is where we make the payment of the reward token, which could be an NFT or any other currency on the Stellar network. Right, and the last point I wanted to talk about is the integration of the Flutter wallet and also the custom types for interfacing and communicating data back and forth between the client and the contract. So let's start talking about the custom types. So here, if you go to the pool Rust file, you can see that we have two tuple structs for ball and pockets. And if I go back to the lib file, you can see the table which contains two vectors for the balls and pockets. It's a struct with name fields, so it's gonna be communicated as a map to the client. And as you can see here, we return the table on successful call to insert coins. So if I go into the client file here, you can see the snooker contract client is where we handle all the communication with the smart contracts. You can dig through this code, but the important part right now is the return value from the Soroban contract. And I'm going to actually show you by logging this data. So this is an scval, Soroban meta, and once we call scval to native, we get an object that we can actually use in JavaScript. So let's save this, let's bring the console, and let's reload that file. Okay, so if I click play, sign the transaction, and as you can see here, we've got the scval, which is a map containing two fields, so one for the balls, one for the pockets, and the fields contains all the data. Once it gets converted, we get a vector of balls and pockets as well. And I use the map here just to convert them into convenient objects so that you can use them in the code. Another point that is important is when you communicate back the data to your contract, then you can use, where is it? Here. Native to scval, so you get your structure in JavaScript. You can create a scval object, and you can communicate a few options as well. Here we want a sign 128-bit integer to be communicated back to the contract for all the values for the velocities of the cue balls, and you communicate that as a parameter to the invocation on the transactions. The last part is the integration of Freighter wallet. Freighter is very easy to integrate to your applications. Just need a few calls. I think it's going to be looking for Freighter here. Right here. So basically, you integrate the Freighter API. You have access to, so you can check the network details. We want the user on FutureNet, and then you can just use it to sign the transactions. So you can get the public key of your user, and you can just send the transaction as an XDR payload to have the user sign the transaction outside of your application and back to your application with the signed XDR, which you can then submit to the network. So very simple integration for Freighter, and that's a very convenient wallet for users that you can provide with in your games. Right, so I hope you found this information useful. If you have any additional question, you can join litemint.gg, our Discord server, and then I'll be happy to help you there. We've been running games on the Stellar network for many years, and with smart contracts it's going to be even more powerful. So I hope to see a lot more projects in the gaming and Web3 and metaverse being built on Stellar. So keep building and see you soon.